Good morning. How's everybody doing? Welcome. We're going to get started in a few, maybe a minute or so. Just wait for a few more people to show up. But how are you guys doing? It's nice to be back on YouTube. I'm currently enjoying the vaguely warmer weather. It sort of feels like spring is kind of inching in, which is making me feel a lot less miserable. Hi, Catherine. Nice to see you. Hello, Semilore. Semilore, am I saying that right? Let me know if I'm not, and I will correct myself. Hello, Andlib. Also, for you, if I'm saying that wrong, I apologise, and please do correct me. Hey, Laura. Hey, Ariadne. Gosh, there's lots of there's lots of names that I am unfamiliar with, but as always, please just tell me if I'm pronouncing them wrong. I'm gonna slowly. You're wrong, but it's okay. All right. If you truly think it's okay, then that's fine. But I will always do my best if you do send me sort of pronunciation guidance. I will always do my best to follow it. Hello, Fataha. I'm gonna start sharing my screen with you, and then we can sort of slowly get started. So today is a year 12 topic, and it's sort of the introduction to rate of reaction and collision theory, and it's Shea-Mallory. Is that right? Shea-Mallory? Is that better? Okay, yes, rate of reaction and collision theory. So the plan is for me to introduce myself, but I will do that in a second. The plan is to sort of understand rate of reaction, to understand collision theory, and then to sort of describe factors that might increase the number of collisions. So we're sort of going to talk about concentration and pressure, but we're not going to talk about temperature, because that's sort of a whole other topic, because you've got to look at Maxwell-Boltzmann distributions and things like that. But yes, so that is the plan for today. So I introduce myself properly now. So if you haven't met me, my name is Georgia. Welcome. I'm the head of education at SnapRevise, and also sort of chemistry person, but you might have met Alyssa, who is also a fabulous chemistry person. I did an MSci in natural sciences, which is a hodgepodge degree, but I specialize in chemistry. And I've been teaching and tutoring for the last 7 years. So hopefully that means that I should be able to help you with some things. As usual, we are doing a giveaway. So if you don't already have an account with us, if you sort of screenshot this class and then post it on your Insta story and tag us in it, then you will be entered into a contest to win a free account. Just make sure that if you have your Insta on private, that you forward us an image, a screenshot of your screenshot in your story, so that we can see that it's actually there, because if it's on private, we won't be able to see it. So be careful about that. Where did I do natural sciences? I did it at UCL, University College London. And also, as always, there's a coupon code at the end that will give you a discount on the website, even if you don't win the competition, and everybody can use that. So that is nice, hopefully. Blah, 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 blah. So I've said what we're doing, so I'll just go ahead and go very briefly through the spec points. So this topic in particular, there's a little bit of difference in the spec between AQA, OCR, and EdXL. I do just mention those on the sides, so don't worry about sort of worrying that I'm not going to tell you when you don't need to know something. But just in general, you should be keeping an eye on your spec point, because it's basically a list of the things that you need to know. And the most common question I get asked by students is, do I need to know that? So there's literally a document. So have a look at those things. So let's sort of get started with the stuff that we should already know from GCSE and before. And the first thing that we need to think about is sort of what is rate. So I don't mean what's the rate equation. I mean in general, if I say the rate of something, what do I mean by that? Yeah, so Laura knows exactly what I mean. But yes, so the speed at which a reaction takes place, yes, it's kind of like speed. What you're doing is measuring the change in something. So speed is a type of rate, right? Speed is like the change in somebody's location or something's location. It's going from A to B, and then you're measuring its change in location over time. So speed is a type of rate, but rate does not necessarily mean speed. So it's the change in something. And you guys are correct in thinking that in chemistry, we're usually looking at the change in a reaction over a unit of time. But yes, that's exactly correct. All of the answers are sort of technically correct. It's just I'm going for the most general way we can look at something. So change in something over time. And then you can also sort of be more specific with that and say per unit of time. So that sort of specifies that you mean per second or per minute, that you have like a unit involved there. So that's what rate is. So I'm going to ask you guys now what collision theory is. And every time I ask this question, I get a bunch of people saying like different conditions of collision theory. What I'm really going for is like, what do we mean by collision theory? Like, what does it describe? What does collision theory tell us about? What's it for? Hello, Kashika. Hello from London, England. So Laura says particles have to collide to react in the correct orientation with E greater than or equal to EA. Yeah, so states in order for the particles to react, they must collide and meet an activation energy, says Nima or Nima. Please let me know if one of those is correct. And Shay Mallory says rate of reaction is the time taken for the reaction to be used up or the product is formed. Yes, that is definitely rate of reaction. So those, we're getting some good bits and bobs for collision theory. So collision theory, it's a theory of how reactions are actually taking place. If instead of just like looking at your conical flask, if you were able to zoom in to look at each individual particle, what would it be doing during a reaction? What does a reaction mean? Nima, perfect. Thank you. Thank you both for everybody who's giving me guidance on pronunciations. I really appreciate it. So collision theory is just the theory that for particles to react, they must collide. So like physically bash into each other. And then there are lots of different sort of like properties of that collision, different things that have to happen during the collision for the reaction to take place, and that's sort of like the content of this class. So those of you saying things about activation energy and sort of orientation, all of those things are sort of properties of collision theory, but I'm just going to put in this bit that for particles to react, they have to collide, and we'll move on to those sort of conditions a bit later on. The last thing I want to ask you guys is what do we mean by activation energy? Because as lots of you have said in the chat, this collision theory is going to involve thinking about activation energy, so it's worth us saying what it is. Yeah, lovely. Yeah, all of those in the chat, perfect. So it's the amount of energy required for a reaction to take place. To take place, to occur, and I should add in there the minimum amount. That's a more accurate definition. So the minimum amount of energy required for a reaction to occur or to get started. Hello, Chemical X. But yes, all of those are lovely, lovely definitions in the chat there. Any questions on this sort of like introductory bit? Please may you know when the year 13 topics will be taught. Basically, I pick these topics based on demand. So if a bunch of year 13s message on Insta or message message us and say, please do YouTube classes for year 13, then I will do them. But at the moment, mostly it's year 12s asking. So basically, we'll do them if you sort of ask, drop us a message. If you have like specific topics that you'd really like to cover, just drop us a message. Honestly, like it's me just picking these based on what I believe you guys want to do. So if you want to do something, just tell me. And do I do organic chemistry? Yes, I do teach organic chemistry. So I'm going to assume that meant there were no questions about this particular slide, but please tell me if at any point there are questions about this particular slide. But I'm going to move forwards. So the first thing we're going to do is just sort of look at rate of reaction specifically and collision theory. So our rate of reaction has a formula. It's about an hour, Mohammed. We should finish like maybe like 1 or just before 1. What is our formula for rate of reaction? Any ideas? Are we doing the rate equation in this class? No, we are not. That's a year 13 topic, whereas this is the year 12 stuff on rate of reaction. So Catherine says change in Y over change in X. That's technically how you would work out the rate from a graph, but not sort of like the overall rate of reaction formula. So Kashika, if you want to do transition elements, drop us a message on Insta because I can't write this down right now. And what's going to happen is I'm going to forget by the end of the class what you asked for, and I'm not going to be able to find it. So please do message us, and then at least I have it somewhere that says it. But yes, so change, people are saying sort of like product formed. Anybody else want to sort of talk about how we might measure? So if we're trying to come up with a formula, there has to be like a numbers we can use. What would we be measuring if we were looking at product formed? You don't have Insta? You can email us also. If you drop us an email at like hello@snapprovise.co.uk, that's also fine. What would we be measuring if we were trying to look at the product formed? Yeah, it could be mass. So mass is a way that we can measure that. How else could we measure sort of product formed? Or yeah, it could be the amount of gas produced. If your product is a gas, it could be exactly, Georgia, it could be concentration. But when we say like the amount of, we need to sort of, if we're trying to actually calculate, we need to state how we're going to figure out the amount of something. So we could be doing concentration of your reactants or your products really over time. We could be doing volume of gas over time. We could be doing, where else am I going to write this? I'm going to write this here. We could be doing mass over time if you're sort of producing a mass from a gas, or you might be losing mass. And then you could measure that as well. So all of these things are the possibilities for the rate of reaction, and all of them should be change in. So I'm just going to write change in on the top of one of them, but all of these you would be measuring the change in concentration or the change in volume or the change in mass. But you have to be measuring something specific. It's not enough to say amount of. Could you measure change in pH? You could, if you knew your reaction was definitely one that was either producing an acid or using up an acid, or producing a base or using up a base. You could also definitely measure change in pH as well. That's also a good measurement tool. So I'm going to write another one. somewhere I will write this. So rate of reaction is equal to change in pH over time. And if we were going to take that first one, so the concentration of reactants or products over time, so that's sort of like the standard one, the most common one used, because lots of the stuff we do in chemistry, we do in solution. So it's reasonably easy to sort of study concentration. What units would we be using for changing concentration over time? So we'll need a unit for the concentration and we'll need a unit for the time. Yeah, so we should be using moles per decimeter cubed because that's our standard unit for concentration in chemistry. And then we should be using seconds. So that just means moles per decimeter cubed per second. Yeah, no worries on that. Yours would have been correct if we were looking at mass, change of mass as well. Cool, so we're running with concentration of products and reactants because that's the most common one. And as you guys have noticed, I have some graphs below. I've got two different graphs. And I'm going to tell you now that one is a graph for the concentration of the reactants changing over time, and one is a graph for the concentration of the products changing over time. Which one do we think is the concentration of the products changing over time? The one on the left or the one on the right? Which one is my products changing over time? The concentration of the products. Left or right? Yeah, it's the one on the left. Tell me how we know that. How do we know that it's the concentration of the products? How does the graph tell you that? Yeah, because more products are being produced, right? As the reaction moves forwards, you have more of the reactants reacting, and then you slowly produce more products. Why do we have this plateau here? Why does it stop? Yeah, so flow's got it. So you've run out of reactants, right? You don't have like infinite numbers of the reactants being put in the whatever container you have in your beaker at once. At some point, you've sort of done as much of the reaction that can happen because your reactants get used up, and then you sort of plateau off. So that's our concentration of products. So I'm just going to tell you that your reactants are the one on the right-hand side because I think it's fairly obvious. Can you guys tell me why this graph on the right-hand side is what about the graph shape tells us it's the concentration of reactants? Yeah, it decreases over time, right? So technically, if your reactants are being turned into products, the concentration of them should be going down over time. And again, we have some kind of plateau at 0, and of course, that's sort of when we've used them all up. So as we are talking about rate of reaction, how would we find the rate of the reaction for any of these graphs at any given time? What could you do with these graphs to figure out the rate of reaction? What do we think? Yeah, so we need a gradient of a tangent. So a tangent is just a straight line that sort of that touches the curve once, right? So if I were to sort of put on, let's say I put some actual times on here. Let's say that's 5 seconds, that's 10 seconds, that's 15 seconds, that's 20 seconds. It's a very, very fast reaction. Do you know what? I'm gonna like add on some zeros just so that the reaction seems slightly more likely. Where is the best place on here to draw our tangent? What is going to be like the most usable spot? Yeah, our initial rate. So at which time is our initial rate? Does it have to be a tangent? Yes, you do need to draw a tangent, and that's because this is a curve. So we're getting lots of people saying some different things. We're getting some people saying t equals 0 and some people saying 50 seconds. I think what's good about what you guys are saying is nobody thinks it's going to be useful to take the tangent at the plateau when all of the product has been sort of produced as much as it can. That's correct. But there's no point looking at the rate when the line is flat, because then there is no rate. The rate is 0. It's not changing. But we also could take it at any point along the sort of actual moving curve. But as a sort of convention, we take the initial rate just because it means that it's easier to sort of compare results with other reactions. Because if you, for example, picked 50 seconds and then you had another reaction that was actually done before 50 seconds got there, you couldn't really compare your results. So every reaction has to be doing something at the first second. So that's pretty easy for us to say, okay, so if we pick t equals 0, then we can compare results everywhere. So that's why we do that. So we are going to look at the tangent at t equals 0. And we would do the same if we were looking at the concentration of the reactants. So we're going to take the tangent at t equals 0. And then on my next slide, we're going to have a go at just calculating that. Are these revision sessions every Sunday at 12? So I'm the only one that does them at 12. So chemistry happens once a month, biology happens once a month, math happens once a month, physics happens once a month for A level. So mostly they are at 5 p.m. So, but I do them at 12, and then I think it's physics does it at 3, because we have like different schedules to sort of squeeze around. But they're every Sunday, just at different times. For the decreasing graph, do we need to draw the tangent below the graph? No, it just needs to touch the line at one point. So if you were to draw it above the graph, you would have to make sure that the tangent was short enough that it wasn't crossing the graph at 2 points. So for example, you couldn't draw it like this, because then it would be crossing at t equals 0 and t equals whatever that spot is. So just make sure it only touches the curve at 1 point, and you'll be all right. Oh, Kashika, I'm sorry. Yeah, it's really tricky for us to schedule things, taking time differences into account. So apologies that only chem is at a good time. Is there any point you could do them more than once a month? It depends, right? Because obviously all of our teachers, we have to pay them to teach. So like we have to balance between like how much we can afford to do for free versus like how much paid work we can afford to do, because obviously the paid stuff has to happen for the teachers to be paid for the free stuff. So at the moment, once a month seems to be a good balance for that. But perhaps in the future, if we get like more and more kids on our platform, then we might be able to afford to do more YouTube classes. It's really like a balance of those kinds of things, because we don't get like government funding. But yes, we try our best to do like as much free stuff as we can. Okay, I'm going to move forwards unless anybody's got any questions about this slide. We will practice doing our gradients in the next slide. Okay, I'm going to move forwards. So we're going to have a look at this, which is actually, you guys are going to tell me which kind of graph is this? Is this concentration of products or concentration of reactants? Anybody? Which one is this? Yeah, so this is my concentration of reactants. So presumably I have iodine. I have I2 as a reactant in some reaction, and I'm measuring my concentration of my iodine across time. So we want to calculate the initial rate, so the rate at t equals 0. So I have happily got the tangent drawn for us already, because as you guys have seen, my tangents are like wobbly, very wobbly. So how will I calculate this rate? So I have a tangent. What am I going to do with it? what shall I do with my tangent? Calculate the gradient. Yeah. And so wombat has already given me change in y over change in x. And so I'm just going to let you guys tell me what sum I should be doing. What is my change in y? What is my change in x? Yeah, so Catherine's saying pick a point that's easy to read off of the graph. I would argue, yeah, so Adriadne is sort of giving some good points to pick. So is Toby, so is Wombat, so is Mohammed. So yes, so I can see that you guys have all sort of picked 1,000 seconds as sort of like an easy-ish point to read off of the graph. And then this 3 moles per decimeter cubed of iodine is pretty easy to read off. So because we're going from the origin to 3, the change in y is 3. And because we're going from the origin to 1,000, the change in x is 1,000, which means that my rate of reaction is what? And please do not forget units. I require units always, unless it's a thing that doesn't have units. Would 3 over 500 work? No. So if you wanted to take the 500 seconds, that's here, it would mean you'd have to go across from where that 500 meets that red line, which would be like 1.5. So you could do 500 over 1.5, Zara. But yes, lovely. So we should have 0.03 moles per decimeter cubed per second. Lovely jubbly. Any questions? Any questions about this? I'm getting no things in the chat. If I like skip forwards and you were typing, still send the question. I'll just go back. Okay, so as I said, our collision theory in its most basic form, it just says that if we zoom in to particles, so we can actually see the particles during reaction, for them to react, they have to sort of like bash into each other. They can't react if they're on other sides of a room. They have to bash into each other. They have to collide. But collision is not the only thing that particles have to do to actually be able to react. So I've got some stuff on this slide, and this is where the exam board differences come in. So activation energy, that as sort of a concept has to be learned by all of the examples that we have that I cover specifically, so AQA, OCR, and EdXL. So this first one is everybody. So can somebody tell me how does activation energy relate to our collisions? What is it in terms of like a prerequisite for our collisions to cause a reaction? It does not relate to collision. It does, Candy, it does. So we have two particles, we want a reaction to happen, they collide. What about activation energy needs to happen there? Yeah, so Sumaya is saying that activation energy is the minimum energy required for reactions in particles to collide. Zara says activation energy breaks all the bonds in reaction. Toby says minimum amount of energy. Flow has like a good sort of combo of some things that people have said. So in order for a successful collision, you must have enough activation energy. So yes, so what we're getting at here is that, let's say your particles are colliding and they're both moving, so their kinetic energy is like turtle speed, so tortoise speed. They're sort of like really, really slow, and then they just like poof, kind of like bump into each other really, really slowly. They may not have enough energy between them for the reaction to actually happen. They may just sort of like bounce off each other instead of like doing the bond breaking that is required for reaction to get started. So even if things collide, they must have energy either equal to activation energy for that reaction or above that energy for the collision to actually lead to a reaction. So you're going to write that down. The colliding particles must have their energy either equal to or above, oh, that is not the right way around, either equal to or above activation energy to break bonds required. So remember that bond breaking requires energy. So if you want to break your bonds in order to make a reaction happen, the particles must have the kinetic energy required to break those bonds. Is everybody following me? Does that make sense to everyone? Yes, no, maybe? And I feel like somebody said, how are you? Like 5 minutes ago and I didn't respond. I'm all right. Thank you for the person who asked me how I was. Yeah, all good? Okay, so that is the sort of prereq for collisions to make a reaction happen required for, can I repeat it again, please? Yes, I can. So for a reaction to take place, you have to have the energy, to break the bonds to get the reaction started. So, you know, like with most reactions, a bond breaks and then two things can therefore get together and make a new molecule. So that bond breakage for a reaction to take place requires energy. You have to put energy in to pull bonds apart, which means that in collision theory, we're saying that these particles, they need to bump into each other. If they don't have enough energy when they bump into each other, those bonds are not going to break and the reaction's not going to happen. So they have to bump into each other with enough force to break the bonds, and then the reaction can take place. And the word we use for that is activation energy. So activation energy is basically like how much energy do we have to put in to break enough bonds that the reactions can sort of like get started properly. So what I've written here is that the colliding particles must have the energy. So usually we're thinking about kinetic energy that is either equal to that minimum amount of energy required to sort of break those bonds or above. So either has to be equal to or above activation energy to break the bonds required to sort of like get that reaction going. Is that feeling sort of a little bit more clear, Mohammed? And I have a question, sorry for interrupting, but your school's not offering chemistry and AS. So is it possible to do A-level in 1 year? You mean like shove together year 12 and year 13 in 1 year? Really, really quickly, I would say like that I don't recommend it because it's hard. It's like I've had like private students do something like that, like when they are from another discipline, they already have a degree and they want to go do like medicine or something. So they do A-level chemistry in 1 year, but usually they have like a lot of time to just shove everything together. If you're doing other subjects at the same time, it's probably going to be really difficult. So like I personally, like if it were me, I wouldn't do it because I wouldn't want to get a low grade because I tried, if that makes sense. But only if you have the time. If you have extra time, then yeah. Okay, sorry. So back to collision theory. So as I said, there are some spec differences here. If you have, yeah, I'm not saying it's impossible. I'm just saying if you don't have extra time, you may end up getting quite a low grade. So the next thing that we need to think about is the orientation of the particles. And this is technically not on AQA's specification, but it does kind of like show up in the book very briefly. But technically it doesn't say that you need to know this for the spec, but OCR and Edexcel definitely do. So orientation, can someone tell me what do I mean by orientation? Collision theory, We've sort of said that they have to collide to react. We've also said that they have to have sufficient energy to react when they collide, but we also need them to be in the correct orientation. What do I mean by that? What does that mean? The position, how the bonds break, the direction of the particles. Yeah, it's kind of about like the angle. The orientation is like the correct position. Yes. And the example I like to use is actually from biology. So I'm going to like scribble this out because every time I show a reaction mechanism, people are like, what? I'm more confused. I'm going to do like the Pac-Man thing from biology, from enzymes. So if you remember your GCSE biology, right? It's not quite the right theory, but it's close. So in biology, for things to react in like biological catalysts, like enzymes, you've got this thing, which is like a catalyst or an enzyme, and then you've got these are the reactants, right? So if they were to collide with this reactant facing the other way, it would not fit inside that little Pac-Man. You would get like something like this. Gosh, it is hard to draw proper shapes. You get something like this, but it doesn't fit properly. So the reaction would not occur. So they're at the wrong angle. Even though they've like collided, the reaction's not going to happen because they've collided at the wrong angle. But if the reactants collide the right way round, they will fit in the little Pac-Man thingy, and then the reaction can take place. So I'm not telling you to memorize enzymes. I'm just using this as a sort of like a pictorial representation of what I mean by orientation. So all molecules have these sort of like angle requirements where some angles, things aren't going to fit together right so that they react, and some angles will be the right sort of fit for the reaction to take place. So the way that you need to describe this, all you need to say is that the colliding particles must be in the correct orientation. And that's all you need to say. I'm just giving you sort of like a diagram so that I'm not just sort of doing kind of like a circular explanation where I'm saying orientation means they need the correct orientation. So that sort of little diagram below is just to sort of explain what I mean, but please don't memorize it. Is that a way of explaining successful collisions? So orientation is a property of successful collisions. So far, we've sort of stated that if we want a reaction to occur, first of all, the particles need to collide. So that's part of collision theory. Second of all, they need to have energy equal to or above activation energy, which is another way that a collision might be successfully leading to a reaction. And thirdly, they need to be sort of at the right angle with respect to each other, so that the reaction actually happens. So that's called orientation. So those are, if we have the right activation energy and we have the right orientation, we're sort of much more likely for a successful collision. And that's the sort of phrase we use to mean the collision resulted in a reaction. That's the language you would need to use in an assessment or an importance. So an enzyme is just like a biological reaction. It's still a reaction. So enzymes are catalysts. They're just biological catalysts. Does that make sense, Candy? I'm lagging quite a lot. Yeah, it's an example. I don't know what to do about this lag. I could try and change the Wi-Fi that I'm using. Am I still sort of, is my internet still being rubbish? It stopped now and it's fine. Okay, all right. Well, let's just hope Let's hope it continues being fine, and then if it doesn't, then I'll see what I can do. Can I ask, because the next slide is Edexcel only. So what I want to get a sense of is if I have any Edexcel people, because if I don't, I'm going to skip it. Do I have any Edexcel? Wombat does Edexcel. Okay, so those of you who are on Edexcel, this is going to be quick, but just know that you don't need to know this unless you are Edexcel. So maybe just zone out if you don't want to hear anything that you don't have to memorize. So there is a third quality. Edexcel is an exam board. So like AQA, OCR, they're exam boards. Edexcel is another one. So Edexcel needs to know a third property of collisions to make them successful. So far we've said to react, particles have to collide. Secondly, they have to have enough energy to overcome activation energy. And thirdly, they have to be at the right angle with respect to each other. And there's a fourth. Is that a fourth? Yes. Sorry, I can't count. There's a fourth thing that particles need to sort of have to actually react when they collide. And it's about steric hindrance. So steric basically just kind of means size. So size hindrance. So like big things get in the way is what steric hindrance means. So I'm going to write a sort of definition, and then I'll talk about what that actually means in terms of reaction. So the size of reactants, so like the physical size, how big is my molecule, how big is my atom? So the size of reactants or functional groups can affect the number of successful collisions. And I don't know if CIE needs to know this. Check your spec. Double check your specification. Just like if you open your spec, just do Command F or Control F and then type in steric and see if it comes up. Cool. So this part is just for Edexcel, but the next thing we're going to do is do an exam question so everybody can join in with the exam question. Just quickly going over this slide for my Edexcel. My Edexcel lovelies. So size matters for reactions to take place. So for example, if I have, we all know displacement reactions, right? So if I have a BR, let's say, if I have a bromomethane, and I want to react with a chlorine ion to make chloromethane, that's going to be quite fast because the methane bit is teeny tiny. So there's a very small amount of molecules that the chlorine has to get past to be able to kick the bromine out. The hydrogens are super small. So that's a very fast reaction and it happens very quickly. But if, for example, one of these hydrogens isn't there, instead we have like a whole other methyl group, perhaps we have two methyl groups. You can see just by the diagram that it is much harder for the chlorine to just sort of like get to the carbon that it needs to get to for the reaction to take place. So that's all steric hindrance means. It means that like the smaller the stuff in the molecule is that's around the place where the reaction takes place, the faster the reaction will happen, the more likely that chlorine will be to get into the right carbon. Whereas if the molecule is larger, so especially if it's branched, it's going to be a lot harder for the chlorine to get into anywhere near that carbon to sort of displace the bromine. So that's all steric hindrance means, just like it's quite logical. Like if you're looking at a molecule, like how much space is there for a reactant to get close to the reacting atom? Are all my Edexcel people, does that all make sense? Yeah, that's perfect. So yeah, exactly. You need to have sufficient energy, so activation energy. You need to have proper orientation, and you need to sort of be able to overcome any steric hindrance. Lovely jubbly. So in that case, I am going to move on to an exam question, and then we're probably going to have to finish up there. because we are running out of time. Are we all good to do an exam question? Yes? Yes, yes. Are we feeling good enough to do that? I can't tell if there's just loads of lag or if like nobody's answering. Yeah? Yay! Okay. Go for it. Excellent. All right, let's do it. So this exam question says, Figure 1 shows the volume of hydrogen gas collected when a sample of magnesium reacts with dilute and excess of dilute hydrochloric acid. The rate of this reaction can be studied by measuring the time taken for a given volume of hydrogen to be collected. And the first part of the question just says, state the meaning of the term rate of reaction. It's not clear. Try upping your resolution or making it full screen. You can change the resolution if you look at the bottom right of the video, or make it full screen and you should be all right. But the first part of the question is just state the meaning of the term rate of reaction. So that's 1 mark. So what do I need to say in that 1 mark? What's the meaning of the term rate of reaction? Ah, beautiful. So Adrienne says rate of reaction is the change in something over a unit of time. So I'm going to sort of like shift that a little bit, because remember that this says not just rate, it's rate of a reaction. So we don't just have to say it's the change in something, it's the change in the reaction, right? So Shamalore says rate of reaction is the time taken for the reaction to be used up or the product form. Kind of. So time taken is not quite right, because it's sort of change over time is rate, whereas you sort of looked at getting from A to B in a specific time. It's not quite rate. Catherine says change in volume of hydrogen compared to time. Almost. That's a pretty good definition if we're looking at that specific reaction. But it just says state the meaning of the term. It doesn't ask for us to use the example. So the best one to do is just to say the change in the concentration. You could have said mass of a product or reactant per unit of time. And that's sort of like perfect standard definition. Per unit. Lovely jubbly. Does it mean generally, or does it mean specifically related to the reaction? So you can tell it means generally just by the fact that it just says state the meaning of the term and then gives the term. So if it said something like state the meaning of the term for this particular reaction, you would say for that reaction, or if it mentioned that reaction in the sentence, then I would do it in terms of that reaction. But just because it says state the meaning of the term rate of reaction, we're all right just to do it generally. So Candy says time taken for the completion of the reaction in seconds. So be really careful, because I've seen this a couple of times in the chat. It's not time taken for the reaction. It's the change in something over time. I realize they sound similar, but they're quite distinct. So when you say time taken, the unit for the time taken is just the time. It's just seconds, or it's just minutes. You need to say change in something over a unit of time, because then you're talking rate, then you're talking like moles per decimeter cubed per second or grams per minute, things like that. So it's really important not to say time taken when you're looking at rate. Okay, last question. Part 2 says state and explain what has happened to the rate of reaction at point W in figure 1, and that's 2 marks. So remember that it says state and explain. So we need to say what's happening. So that's the state bit. And then we need to explain why it's happening. And that's your 2nd mark. Oh, I'm getting some good answers in there. So Wombat has started by saying the rate of reaction is 0. And Shemalore says the rate of reaction has stopped. I think you might just like grab a mark if you had a kind examiner for the rate of reaction has stopped, but a better way of saying that is the rate of reaction is 0, because it's like describing directly what you've seen on the graph. But you might, maybe, if the examiner is being nice. So those of you saying the reaction has stopped, remember that it's asked you specifically about the graph. So when you guys are saying the reaction has stopped, you have to be careful, because that's your interpretation of the events in the graph. So that's the reason, but it's not the state bit. So you guys saying the reaction has stopped, that's your explanation. For the state, you have to say what you're seeing on the graph. And what you're seeing on the graph is the rate of reaction being 0. So here we can say the rate is 0, and that's the state bit. So actually, I'm going to put that in red. So that's my state. So the describing it, oops, I did not mean to do that zoom in, sorry, is the rate is 0. And then the explain bit is the other thing you're saying. So the rate is 0 because the reaction is complete. Or you could say the reactant has been used up. Either are fine. Just make sure, like, I think some of the best things you guys can do for assessments is just to really get a hang of interpreting those command words. So like knowing what it means by state and knowing what it means by explain and getting used to like doing those things. But yes, you guys have done super well. As usual on YouTube, I don't get through like, I get through like half the amount I do in a usual class just because there's so many more of you here. But I've enjoyed myself very much. So I'm going to just skip to the end and say, do you have any questions before I do like the whole, this is what SNAP provides, and please sign up to our platform if you can, and we would love to have you there. Do you guys have any questions? You're welcome. Any questions? You're welcome, Chloe. When do we find out who wins You Did an Insta thing? Do you know what? I don't know. One lovely colleague who is possibly in the chat right now. Do you know when the Insta thing is announced? You're welcome. When is the next lesson? So the next chemistry one is next month. But the next just like YouTube class for A-level is next Sunday. Awesome. All right. So you should know what rate of reaction is. You should know what collision theory is. And you should be able to, well, you can't do the last bit because we did not do that bit. So scrap that last bit. You shouldn't be able to do that yet. Do particles concentration affect activation energy? No. It affects the number of collisions, but it doesn't affect the kinetic energy. How do you stay motivated? Oh, that's a hard one. I think if you're finding motivation difficult, you kind of have to like look at why, and then you've just put that in the chat. So you said you can't study in lockdown because it's really hard to remain concentrating. So there's like a few things that I would suggest. So like, for example, I just completely fail to concentrate past 3 p.m. So I know that if I need to do anything that's going to take a lot of brain power, so like if I'm trying to learn something new or I'm doing something like really brain intensive, I know for me personally, I have to do it in the morning or I'm never going to do it. Or for example, I hate housework. So I do the dishes as soon as I wake up because that's when I have the most like willpower to make myself do stuff. So try to learn about yourself, try to figure out when is the best time of day for you to like do stuff you don't want to do or stuff you're finding difficult. So that's like one thing you can do. Then like treats are also helpful for some people. I don't find they work for me because I just end up eating a bunch of cake and then not doing the things I'm supposed to be doing. But I know some people like it really works for them to be like, okay, so if I get past an hour, I'll give myself this treat. Third bit of advice is probably just like figure out the stuff you need for good well-being, because it will be easier to motivate yourself if you're not like exhausted and drained and sad. And so like, for example, playing the piano makes me really happy, so I make sure there's always time for that in my day, and that makes it a bit easier to do the things I don't want to do. So those are 3 bits of advice. I don't know if they're helpful. I did like a whole YouTube series on this channel called like dealing with feelings of exam stress and anxiety, and there's like a whole video on motivation and procrastination. Go watch that also. It's like there's like a playlist of it. Find the one about procrastination and motivation. What is, somebody else said something. Is there a possibility that A-levels will be cancelled? I don't know. I don't know, JMP. Ask the Secretary for Education. I have no idea. Cannot predict. For you can't use revision cards or such stuff to revise. You're more repetition. That flashcards. Yeah, so like exactly, like get to know yourself. That's going to be like the most important thing for studying. Like get to know what works for you and what doesn't, like you have with your flashcards. But I'm going to move forwards and do like our whole thing where I show you the website, because that is part of the reason that we come to YouTube land. But if you know you don't want to sign up, you don't have to stay, of course. Screen sharing is paused. Okay, cool. So I'm going to just like go on our website now and show you what we do. Is it possible to get 3 A stars? I mean, like, yes, technically it is possible technically to get 3 A stars. Okay, let me open our website things, and then I will show you things about our website. Okay. All right, so this is our pretty website. So part of the things we do on the website is these web classes, but we've done sort of a lot more. So you can do lots of different subjects. I'm going to show you chemistry, of course, because that is my subject. So what we have in chemistry is like the whole course on here in like video form and exam question form. So you might begin at the beginning and click on fundamental particles. Oh no, because I've already done that, it doesn't work. One second, I have to click on one that I haven't done. So let's say I haven't done electronic configuration yet. So the first thing you do on our website is take like this diagnostic quiz where we ask you a bunch of questions and they're self-marking, and then it tells you sort of like what you know and what you don't know. So for example, I didn't know what my orbitals were called and about my p orbitals in the 3p subshell. And I'm struggling with my energy orders, and oh no, I also can't do my nitrogen configuration or my oxygen one. Oh dear. But I do know that 2D orbitals don't exist, blah, blah, blah. So I go through my whole quiz and I get a list of the things that I was good at, and I get a list of things that I was perhaps not so good at. And then what happens is we take you to the videos and we show you which part of the videos that you need to watch. So I would not need to watch about electron shells, but I could click on atomic orbitals and it would skip forwards and show me that. So that's like the first thing that you get on like our basic package. So that's the cheapest one. So you would still get this, and then afterwards you have sort of like exam question walkthroughs also in video. So we'll walk you through exam type questions, but we also have like exam packs. So that's on like the second next more expensive tier. So basically we spent a really long time writing a ton of questions. It took a very long time, because the thing we hear most from students is that you run out of exam papers to do. So basically we came up with a bunch of exam style questions for you to do. So those are there. We also have nice revision guides for lots of our topics, and sort of like, last of all, in the sort of most expensive package, you get like these web classes. So for chemistry, there are 5 a week. So this evening, Alyssa, my lovely, lovely colleague, will be taking a year 13 class on weak acids and bases. So you get like a bunch of stuff. You get me teaching you some classes on Tuesdays and Thursdays, and you get Alyssa on Wednesdays and Sundays, and then of course we have all of the other subjects. So that's basically what we do. Feel free to sign up. We love having you, but if you can't afford it and it's just like not within your sort of price range, then of course we're still here for you on YouTube. So still just come to these. And I think that's all I wanted to do, apart from give you the code for the discounty things. Blah, 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 blah. Blah, blah, blah. Sorry, I'm just trying to open my PowerPoint again and failing to do that quickly. Okay, perfect. So upcoming web classes, do set your reminders. That is reasonably important. And here is your discount code. So Wombat's just asked, with the account giveaway, how much of the site can you access and for how long? Also, colleague, if you know the answer to that, please drop it in the chat. Is chemistry a hard A-level? You're extremely anxious. So like it's all relative, isn't it? Some people find it very hard. Some people find it like very manageable. I really feel that you like should just go check out the exam stress and anxiety series, because feeling anxious about something is not necessarily like a good representation of the reality of that thing that you're feeling. So I would sort of like try to look up some anxiety resources if you can. But yes, I'm gonna go. It's 1 o'clock. I'm gonna go like, I don't know, do Sunday things. Yeah, have a lovely day, guys. It's been a pleasure.